We're going to factor when the leading coefficient is not 1 on a trinomial. A lot of times they'll write like this. An example, 3x squared plus 22x plus 7. Now, there are different ways of doing this. Some people may not like this way, but I think this is the easiest way. But you have to be careful here. Make sure there's no GCF, and there's not. So we're going to multiply 3 times 7. It's 21. We're looking for two numbers which multiply to 21 but add to 22. Now, if you're doing a trinomial, the leading coefficient 1, you're trying to multiply to 7 to add to 22. But when we have this coefficient that's not 1, for at least this process, you need to multiply here. Now, factors of 21, it's a pretty short list. You have 1 and 21, you have 3 and 7. And the ones that add to 22 would be 1 and 21. Okay, so x plus 21, x plus 1. Now, clearly this is not correct, right? Because if I multiply this together, there's no 7. You want to come out of this, there's no 3. So what you want to do is divide by 3 here and here to compensate for where I multiplied it there. And then we want to attempt to simplify these fractions. It's possible that neither will simplify. It's possible that only one will simplify. It's possible that both will simplify. For example, 21 divided by 3 is 7. You definitely want to simplify. If you fail to simplify it, then it's not going to work. 1/3 does not simplify. So I'm going to write it like that. Now, to finish, what you're going to do is take any denominator left, which there should be at least one denominator, if not two, and you're going to move it up here. Okay, so it becomes 3x plus 1. A little tricky as to exactly how that works, but it will work every time. Now, if you multiply these back together, you're going to get this. And if you were to factor it a different way, then maybe the 3x plus 1 would be in front. Matter of fact, had we put 1 here and 21 there, 3x plus 1 will be in front. But this does work every time. All right, so let's look at a couple other examples to just give you some experience here. We'll do 6x squared. We'll put a minus 5 in the back. Let's go with 13x here. Okay. Again, we're going to multiply first. The leading coefficient times the constant. That's negative 30. We're going to think about the things that multiply together to give 30. Now I'm going to list them without considering the signs here. 1 and 30, 2 and 15, 3 and 10, 5 and 6. And as you well know, it's not necessary to make that list. Actually, if you can think about what makes the number without writing the list, and by all means, you don't have to write the list. Now, there are two possibilities here that could possibly add to 13. So I'm going to multiply here and add there. Now, if I'm being flexible here and I'm considering both signs that I could actually either add or subtract, then maybe this works because 15 minus 2 is 13. And maybe this works because 3 times 10 is 13. If you're not sure which one works, you'll just try one and see if you can get the signs to work out. Okay, so I'm going to try the 15 and the 2 first. Now, as I've said in a different video, what I think is very wise is to write the larger number first before you consider signs, so that you're guaranteed the larger number will always match the first sign. It never fails. It will always work. So the plus goes here. Now you have to think about this sign, though, to see if it works. Remember, you're trying to multiply to negative 30. 15 times, okay, you're going to need a negative here to be able to multiply to negative 30. Now, we had two different rows that potentially could have worked, so we need to make sure it adds to the middle, okay, because it's possible that we can get the multiplication to work, but the addition doesn't. But here we're good. 15 plus negative 2 is, in fact, positive 13. Had I tried to put 10 and 3 in there, you could either get it to multiply or to add, but you could never get it to do both at the same time. So this is correct. But remember, we've got this 6 here, so we're going to divide by 6. Okay, and you must reduce. If you don't reduce here, you're going to be wrong. 15 sixths, each of those have a 3 in it. So I'm going to divide by 3 and get 5 halves. 2 and 6, each of these have a 2 in it. Okay, so unlike our first example, they both simplified here. Also, they both still have a denominator. So we're going to move those denominators to the front, and we're going to leave the numerators where they are. So 2x plus 5, 3x minus 1. It's a little tricky again. Seems kind of like a magic trick. It's not easy to see exactly why this works. And that would be a separate video just to show that. It would take some time to show that. But it does. It always works, this process. Again, you can multiply those together to see, to ensure that it does in fact multiply to that. One last example. Okay, they're all pretty much the same. Just remember, it's not going to work if there's a GCF in the original problem. You need to take that out. It's also not going to work if you fail to reduce the fractions. Sometimes neither fraction reduces, but you always look to try to get that to reduce. Let's try something like this. Let's try 9x squared. And we'll go minus 15x plus 4 here. Okay, again, 9 times 4 is 36. Moving a little more quickly this time. Factors of 36, there are quite a few. 1 and 36, 2 and 18, 3 and 12, 4 and 9, 6 and 6. Okay, I'm trying to make 15 out of that. You can't hear, you almost can't hear that would subtract to 16, but that's your winner. That's going to be the only one, 12 and 3. So put the bigger number first. 12 is larger than 3. The 12 must match that sign. To get it to multiply to a positive 36, this would also have to be negative. Notice that negative 12 plus negative 3 is also negative 15. You want to check that as well. Add here, multiply there. Okay, got to divide by 9. I must reduce. Okay, if you neglect to reduce fully, then it's going to be wrong. Divide both of those by 3. Okay, that's going to be 4/3. Divide both of these by 3. That's going to be 1/3. Then kick both those 3's to the front. Okay, and then you can check that 3x minus 4, 3x minus 1. It works every time. It's a nice method. But again, make sure there's no GCF in the original. Make sure you reduce these if possible. Okay.